All right, we finished that last video with this example here. I'm going to let you try this multiple choice one on your own. I think you can use the sum rule and the constant integral of a constant rule. I think you'll be able to get this guy. So next big idea for this section, the average value of a function. We talked about average velocity being the change in distance divided by change in time. But now we also know that change in distance is the area under the velocity curve between two time values. So if you think about this as the area of the velocity curve, area under the velocity curve, and this as the dividing by the change in the time, we have a new expression for average velocity. So we can actually extend this idea to other contexts that aren't about velocity and acceleration and distance traveled. We can talk about the average value of a function. So this is an important one. There's a place for it on your important facts paper. The average value of a function. The average value of a function f over the interval a to b is 1 over b minus a times the integral from a to b of f of x dx. So we're going to use that new definition here in this problem. I have a metal wire. I know it's 8 centimeters long, and there's something heating it at one end. And I've measured the temperature along the wire at these different distances from the fire. Okay, so letter B, write an expression in terms of T of x for the average temperature of the wire. I see now that I didn't specify. It would be very clear to you on the AP test. I think I just modified this problem a little bit. So the average temperature over the distance is 0 to 8 centimeters. Because there has to be something there to tell you what your A and your B are. So your A, in this case, 0, and your B, 8. So an expression in terms of T for the average temperature of the wire. I'm going to do that part first, and then I'm going to answer the second sentence. So I just learned that formula. If T of x is the temperature, and I want an expression for the average temperature from distance 0 to distance 8, that's going to be 1 over 8 minus 0 times the integral from 0 to 8, T of x dx. If you wrote that on the AP test, that's worth 1 point right there. All right, so the second sentence says estimate the average temperature of the wire using a trapezoidal sum with the 4 subintervals suggested by the data and give units. So here we have, that's one interval, the second interval, the third interval, the fourth interval. Remember, a Riemann sum, or in this case a trapezoid sum, can be used to estimate area under a curve. So we're going to be using a trapezoid sum to estimate that part of the expression. The 1 over 8 minus 0 is still going to be, we're still going to need to use that in our answer. So this is what I'm going to write. I'm going to write 1, that's a 1 over 8 minus 0 is just 8. Feel free to simplify that. Times. Now I'm going to write my trapezoid sum. So the distance across the first trapezoid is 1 centimeter, and then the average of the heights, that's 100 plus 93 over 2, plus the second trapezoid has a width of 4, 93 plus 70 over 2. The third trapezoid, a distance of 1, average the heights, so 70 plus 62 over 2, plus one more. Am I going to fit it in? So difference of a distance 2 across. Thank you for your patience with me. I'm going to try to sneak that in. That's going to be 62 plus 55 over 2. So that is an expression for an estimate of the average temperature of the wire across the whole distance, the 8 centimeters. So I'm going to ask you, in this case, to get a calculator and actually add this up. You have no obligation to simplify this answer on the AP test. But I want to talk about things you can do to check to see if your answer is in the right ballpark. There's a common error here, and if we double check your answer, we'll be able to avoid that common error. So I'm going to pause. I'm going to add this up and see what I get. All right, so here's what I got. I got that is equal to 1/8 times 605.5. So I bring it up because sometimes in this context, we forget to leave this 1/8 in our answer. So if maybe you had forgotten the 1/8, I want you to think about that number 605.5. If I asked you if the average temperature of the wire is 605 degrees, I hope you would look at the temperatures that we know. Maybe you can't look at that and figure out the exact average, but it's it works like averages. So if the lowest is 62 and the highest is 100, the average has to be somewhere in between those. So if you added up your answer and you got 605, I hope you would stop and say, oh, that can't be an average temperature. And you would remember, I hope, to make sure you divide it by your 8. So 605.5 divided by 8 is 6875? 6875. And then we have the question of units. So you could try to reason through it. We were asked about the average temperature, and temperature is given, in this case, in degrees Celsius. Or you could think about it this way. Think about the units on T of x. That's degrees Celsius. Every height of a rectangle or height of a trapezoid is going to get multiplied by the distance across the trapezoid. So in this case, x is measured in centimeters. So that's degrees centigrade times centimeters, degrees Celsius times centimeters. And this 1/8, we have to think about the units on that. So the 8 came from 8 minus 0. Those each have units of centimeters because they're x values. So this is 1 over centimeters times degrees Celsius times centimeters. Notice that these guys are going to cancel to give our answer in degrees Celsius. Final answer. So here we have picture L of t. It's a function that tells me how many cars make a left-hand turn at an intersection at over some time that they've collected that data for. So the first part of this question, traffic engineers will consider turn restrictions when L of t is greater than or equal to 150 cars per hour. Find all values of t for which L of t is greater than or equal to 150. So that's not actually a calculus question. This is a skill, though, that you're expected to know for the test, which is if this is 150 cars per minute, can you find out that time value and that time value? This will be all time values in between those times when there's more than 150 cars per hour that are turning left. So I'm going to show you how to do that on your calculator. We'll see if this works. Nope. All right, so I've typed that function in, and I've set my window so that it looks like the graph. Let's get the problem up here. So I want to know where this graph crashes into the line y equals 150. So that's my second thing that I'm going to graph. I'm going to graph y equals 150. And what I want are the two intersection points, here and here. So the way to find that is to use the calc feature. So that's second and calc. And you want to use the intersection function. So to make that happen, choose intersect. So your calculator is going to prompt you to just confirm. So here it's saying the first curve is going to be my L of t curve, so I use enter to say yes. It says the second curve is y equals 150. I'm going to use enter to say yes. And it's saying guess. So should I actually go and perform that calculation? You're going to say yes. So you can see the cursor lands on the first intersection point. And you can read it to, you're going to, here we go, need to write an integral with that as its limit. If your final answer needs to be correct to 3 decimal places, you should probably write down 5 or 6 decimal places here. You're only going to get scored on whether the first 3 are correct, but if you want your final answer to be correct to 3 decimal places, I'm going to recommend 5 or 6 decimal places in this answer. To get the second intersection point, you're going to use that same process, but you'll want to move the cursor closer to where the second intersection occurs so that the program the calculator runs finds the second intersection. This is second, calc, intersect, enter. So first curve is y. So I left my cursor in the wrong spot, even though I thought I had moved it. I'm going to try one more time. Second, calc, intersection. I'm going to move my arrow here. To hit enter, enter, guess. Now it gets that second intersection. So I'm going to write that down. That was 16.1216 and 12. All right, so I'm going to start with that first answer, which is L of t. L of t is greater than or equal to 150 when 12.4283 is less than or equal to t, which is less than or equal to 16.1216. Again, not a calculus question, but you will need to be able to perform that, demonstrate that skill of finding where 2 functions intersect to solve an equation. And now I'm going to write an expression for the average value. So I'll compute the average value. So this would be 1 over, you might find that you want to write A equals 12.4283 and B equals 16.1216, and then write the expression 1 over b minus a, the integral from a to b of L of t dt. Then you can type that into your calculator to evaluate it. And we'll have to figure out our units, indicate units of measure. That is going to be so L of t is measured in cars per hour. dt is measured in hours. And we have 1 over b and a are both measured in hours. So watch this. That's 1 over hours times cars per hour times hours. So these hours cancel. All right, final answer is going to have units of cars per hour.